So let's learn how to take derivatives of parametric equations. So a parametric equation in general looks like this. X is some function of t, y is a different function of t maybe, and t takes values in some range. So to take a derivative, I'm going to suppose that I can take my function y and write it as a function of x. Just like we saw in Calculus 1, I could take y and express it in terms of x. Maybe you could do that with your parametric equation. Well, if you can, and x is equal to little f of t, then y is really a composition of two functions. I could take the derivative of a composition using the chain rule. So what we have is the derivative dy dx. Actually, let me do dy dt. The derivative of y with respect to t will be the derivative of these two functions composed. Now I use the chain rule, so I get f prime of f of t times the derivative of little f, chain rule. Now, rewriting this a little bit, this is f prime. Now, little f of t, that's my x, so I get f prime of x, that's y prime with respect to x, times f prime of t with respect to t. Using the notation that I used over here for the derivative, the fractional notation, I get this is dy dx, and this is dx dt. Now, derivatives are not fractions. They're derivatives. But sometimes they behave like fractions, and this is one of those times. It looks like you could cancel the dx's. In this case, you can and get a true statement. So here is the moral of the story. I could take this and divide by dx dt, and I could find that the derivative dy dx is equal to dy dt over dx dt. So this is how you take derivatives of parametric equations. Okay, let's do an example. Let's find the line tangent to. How about the parametric equation x is the square root of t and y is 1/4 t squared minus 4. And let's find the line tangent to this parametric equation at the point 2, 3. Okay, so here's how you would do this problem. To find a tangent line, you could find the slope of the tangent line by taking a derivative, and then you could plug in a point to find the actual line. So the slope of the tangent line I can get by taking dy dx. Now using this up here, I get dy dt, so I'm going to take the derivative of this with respect to t. So dy dt happens to be t over 2, taking the derivative. And I'm going to divide that by dx dt. So the derivative of x with respect to t, I think that's going to be 1/2 t to the negative 1/2 power. So I think if you simplify this, you get t to the 3/2 power. So that's the general derivative, but I care about what's happening at this point. Now, how can I get the point 2, 3? What t value do I plug in for x and y to give me the point 2, 3? Well, if you look at the x value has to be 2, which I guess means t has to be 4. So at t equals 4, the slope is 4 to the 3/2 power, which is 8. So the slope of my tangent line is 8. So the actual line is y minus 3 equals 8 times x minus 2. Okay, join us in our next video for another example of derivatives of parametric equations.